The first question is asking us to write the number 16,037 in figures. So that's exactly what I'm going to do right now. So 16,000, so we know that should be over here with a comma, and it says and 37. So we need our 0 in the hundreds place, then our 37. Write down the 6 factors of 28. Now, a very simple way that you can figure out the factors of a number is through your factor pairs. Think about what numbers you can multiply to get 28. So I can do 1 times 28. This is just my rough work to the side. You can do this mentally if you're able to do so. 1 times 28 gives me 28. 2 times 14. I also have my 4 being multiplied by my 7. So those are the 4 ways that we can get 28. So I'll just write them down in ascending order: 1, 2, 4, 7, 14, and 20. Write 9,876 to the nearest thousand. So the first thing that I do is I go into the thousands place. The 9 is in the thousands place. I look at the number to the right. So the number to the right of the thousands place is your 8, right? So I went into the thousands place, which the 9 is in the thousands place, but I'm looking to the right. Now, why am I looking to the right? The reason I'm looking to the right is I want to see if the number to the right is 5 or more. If the number to the right is 5 or more, then I round up. If the number to the right is less than 5, I will round up. No, the number to the right is an 8, so that is of course 5 or more, so I will round up. How do we round up? To round up, we add 1 to the place that we're rounding to. And since we're rounding to the thousands place, I will add 1 to the number in the thousands place. So when I add 1 to 9, I get 10, and everything after it zeroes out. So the answer is 10,000. Pictogram shows the number of different colored cars a garage sells in a month. And we have our key down here. So the key is telling me that each of these blocks represents 12 cars. And it's asking us to work out how many more white cars than red cars the garage sells. So we have our white cars here, and we have our red cars here. Now, since this key is divided into 4 different boxes, I can think about it like each box represents 3, because 12 divided by 4 is 3. So this 12 divided by 4 gives me 3. So I can look at it like each small box represents 3, and of course my big box still represents 12. So that's how I want to think about it. So when I look at the white versus the red, I'm saying, okay, I can clearly see that the white has 2 large boxes more than the red, but then there's also this little bit that's missing. So these 2 large boxes that are right here, that would have been 12 plus 12. And then that little portion that's missing right there would have been a 3. So when you add up everything all together, you get 27. Write down the reciprocal of 5 over 6. So that's simply 6 over 5. And you can also write it as a decimal, which would have been 1.2. The question says, this is Edha's method to work out 99 times 27 without using a calculator. So what I will have to do now is I will have to say, okay, how did Edha work that out? The person said 99 times 27 is equal to 100 times 27 minus 27. So therefore 99 times 68 would have been 100 multiplied by 68. Then you subtract 68. So now 100 times 68 would have been 6,800. And then 6,800 minus 68. So I'll just quickly scribble that here. Just quickly do the subtraction. 7. So 6,732 is that answer. Alright, so let's write 5:26 p.m. using the 24-hour clock. So 5:26 p.m. is of course afternoon. So then I will say, okay, if I know noon is 12, then I will go ahead and add 5 to that. So if I add 5 to 12, I'm currently at 17. But what about the minute portion? I'll simply just write 17:26. And of course, remember to write your answers on the line. All right, so let's figure out how far 21:15 is from midnight. So if I had added 45 minutes onto here, then I would have been at 22 hours, right? So if I added 45 minutes on, I would have gotten to 22 hours. And then if I'm at 22 hours, it takes 2 more hours to get to midnight. So I'm currently 2 hours and 45 minutes away from midnight. So 2 hours and 45 this for properly 45 minutes away from midnight. And then I have to go ahead and say, oh, I'm ending at 4:33 the next day. So I have to go ahead and I have to add 4 hours and 33 minutes to that part. All right, so let's go ahead and quickly add that up. I'm going to see if I can write this a little bit neater. Just like this. So 45 plus 33, that's equal to 78. So if I'm at 78 minutes, of course, that would mean that I would have passed an hour, right? So if I'm at 78 minutes, that means I would have passed an hour 18 minutes ago. So it's essentially 18 minutes here, and then the hour that I passed, I just bring it up here. So it's 7 hours and 18 minutes. Number 9 says, put one pair of brackets into this calculation to make it correct. So there are several ways that you can do this problem. One of the easier ways to solve it is just kind of seeing, okay, what if I had put the brackets here? Then I'd have to do 150 minus 17, which is 133. Then if I minus 5 and times that by 2 to the power of 2, I would definitely not get 32. So that's definitely not where I want to put those brackets. Another place that we could put these brackets is around here. No, of course, we have to do what's inside of the brackets first. So I have 5 times 2 to the power of 2. So that's 5 times 4 on the inside portion, and that's 20. Then I have 150. You write this down, 150 minus 17 minus 20. No, that's not going to give me my answer of 33. So what I want to make sure that when I'm subtracting, the number is big enough because I'm minusing from 150 to give me a 33. So if I'm minusing a small number like 10 from 150, I'm not going to get 33. So how can I make the number bigger? Look at this. So this is the actual answer. I can put my brackets here. Let me write this a little bit better. Now notice in this one, the power of 2 is on the outside of the brackets. So essentially, I'm doing 5 times 2 first, and then I'm squaring that answer. So that's 150 minus 17 minus the square of 10. So that's 150 minus 17 minus 100, and that gives us 33. So yes. Now we're going to jump down into number 10. Number 10 tells us to work out the square root of 5 times 6 to the power of 2. The square root of 5 times 6 to the power of 2. And of course, that is just something that you can punch on the calculator and get. So that gives us 80.50. All right, they want 2 decimal places. So we have to give that to get our full marks. Joe thinks of a positive number n. He squares n, then adds it to negative 24. How Joe thinks of a positive number n. He squares n, then adds it to negative 24. The answer is 25. Work out n. So essentially, I take my n, I square it, Then I add this to negative 24. So let me actually write this a little bit neater. So I take n, I square it, then I go ahead and I add it to negative 24. So negative 24, and then I add my n squared, and that gives me 25. So now my task is to work out what n is. I can add 24 to both sides just to get rid of this negative 24 here, because if we're trying to solve for n, we want n on one side by itself, right? And if I want n on one side by itself, I have to get rid of this pesky negative 24. Now, how can I get rid of that pesky negative 24? I do the opposite. Now, the opposite of minusing 24 is adding. So if I add 24 on the left and I add 24 on the right, then I'll be able to solve. Now, why do I have to do this? An equation is like a seesaw. It has to remain balanced. Anything I do to one side, I must do to the other side. So if I add 24 on the left, I have to add 24 on the right. So negative 24 plus 24, that zeroes out. So n squared is equal to 49. And from our times table, we know that the square root of 49 is 7. Indrani and Jagad share some money in the ratio. Indrani to Jagad is 7 to 9. Calculate the percentage of the money that Indrani receives. All right, so Indrani is getting 7 out of a total of 16. How did I get 16? I have to add my 7 and my 9 together, and that gives me 16. So it's 17 out of 16, and then I would have times that by 100. Again, this is a calculation that you would just punch on your calculator, 7 over 16 and times it by 100, you should get 43.75. The equation of a line is y is equal to 5x plus 7. Write down the gradient of this line. Now we know from the slope-intercept form, y is equal to 5x plus 7. I can think about it like y is equal to mx plus c, where m is my gradient or my slope, and c would have been my y-intercept, which is where the graph cuts the y-axis. So our gradient, we just write it down as 5. Find the coordinates of the point where the line crosses the y-axis, that's the y-intercept. We already have the y value from here. Let me just remove some of this writing. We already have the y value, or 7. And then the x value for your y-intercept would have been a 0. Because think about it like this. If I have a graph and it's crossing the y-axis at a particular point, automatically the x value is 0. Find the coordinates of the point where the line crosses the x. Now think about it like this. Where the line crosses the x, I'm going to actually change this to red. Where the line crosses the x, notice that y is 0. So the line crosses the x-axis where y is 0. So all I have to do is I have to go ahead and I'm like, okay, y is equal to 5x plus 7 is my equation, and where y is 0, I just simply substitute my 0 in, so 5x plus 7. I can minus 7 from both sides, so negative 7 is equal to 5x. And then I can divide both sides by 5, so I have negative 7 over 5. All right, so that's my x value. And in this case, my y value would have been 0. Grid, draw an image of triangle A after reflection in the y-axis. So of course, this is our y-axis right here. And if we're reflecting it, so this point here, after I reflect it, so it's currently 1 space away from the y-axis. When I reflect it, it will be 1 space away over here. So I just put a dot. Up here, I am 3 boxes away from the y-axis. So when I reflect, I'll be 3 boxes away on this side. Over here, I am 1, 2, 3, 4 boxes away. So then I would have been 4 boxes away on this side. 1, 2, 3, and 4. So I just come right here. to erase these lines and draw my triangle. Of course, you will use a ruler. I'm doing it freehand, hence it's not so perfect, but once the coordinates are correct, you will get your answer. Now, typically they ask us to label the triangle as, let's say, A prime or triangle B, but in this case, we weren't told to do so, so I'm going to leave it empty. Triangle A after a translation by the vector -3, -4. So I'm going to have to go ahead and take this same triangle A, and I'm going to have to move it by the vector -3, -4. So this one is also pretty simple. What we're going to have to do, notice that I have -3 up here, and then I have -4 down here. So that -3 is representing the movement on the x-axis, and the -4 is representing the movement on the y-axis. So let's go. Taking this point, currently it's at 3, 5. So the coordinate of this point right now is 3, 5. I am going to move it by 3 units to the left because it's -3. I'm going to move it by 3 units to the left, and I'm going to move it 4 units down. So 3 units to the left and 4 units down. So if I go 3 units to the left, and if I go 4 units down, 1 point is right here. For the next point, this one, it's currently at where x is 4. For the next point, it's currently at x is 4 and y is 2. So I'm going to go ahead and I'm going to move it by 3 units to the left. So that's 3 units along the x and 4 units down. So 3 units to the left and 4 units down. Be right here. So I went 3 units, 1, 2, 3 to the left, and 1, 2, 3, 4 down. All right. Now the next one, let's actually make sure that this is pretty bold. Now the last one that I have to do is this one. It's currently at 1, 1. So I'm going to go 3 units to the left and 4 units down. So 1, 2, 3 units to the left, and 1, 2, 3, 4 down. Okay. Draw my triangle, of course, use a ruler. And there we go. Number 15 is asking us to write 0.0001 as a power of 10. So what I will have to go ahead and I'll have to do is I'll say, okay, I move my decimal point how many times? 1. I'm going to write this number a little bit bigger so that you can see how I am moving the decimal. Move it 1, 2, 3, 4 times to the right. So that is 10 to the -4. As the temperature rises, people seem to eat more ice cream. As the temperature rises, people seem to eat more ice cream. So essentially, as my temperature goes up, the consumption of the ice cream goes up as well. So that is a positive correlation. Sanjay invests $700 into an account paying simple interest at a rate of 2.5% per year. Calculate the value of his investment at the end of 6 years. So our simple interest formula goes like this. Principal times the rate times the time over 100. And of course, your time has to be measured in years. So I am going to first go ahead and calculate the interest. The principal is 700. The rate is 2.5. And the time is 6. Then I'll divide that by 100. So this is just something that we are going to go ahead and punch on the calculator. Now, what is this that I've just gone ahead and written down? Currently, we are calculating the simple interest. That is just the amount of money that Sanjay is making on his investment. So if the question is asking us for the value of his investment, of course, I will have to take my simple interest and add in what I invested. Because if I invest $700, right? And I get a certain amount of interest on that money. At the end of my time period that I have invested for, I will have $700 that I invested plus any interest that I would have accumulated on that particular investment. All right, so this type of question can be asked in several ways. You can just be asked, okay, what is the interest? Or you can just be asked, what is the value of the investment? So the interest after calculation, I'm gonna go ahead and punch this in. Is equal to 105. And I'm making sure not to write it on the line. It's not my answer. So that 105 is just your simple interest. So the value of my investment is 805. How did I get 805? $700 that I invested plus $105 in interest. So ensure you write your answer on the line so that the examiner can clearly see that you understand. Here are the first 4 terms of a sequence, 1, 23, 45, and 67. Write down the next 2 terms. What I will have to do is I will have to go ahead and see how much the sequence is going up by each time. Notice that it's going up by 22. All right, so the next 2 I have to say, okay, 67 plus 22, and that's 89. And then after that, 89 plus 22 is 111. Find the nth term. Now, our nth term formula goes like this. An is equal to the first term plus n minus 1 multiplied by the common difference. So the first term is 1. And then I have n minus 1, because we're still trying to find the nth term, so I'm not replacing n with anything, times d, which is my common difference. So now I'm just going to go ahead and simplify. An is equal to 1 plus, so I'll expand these brackets here, 22n minus 22. So An is equal to 22n minus 21. Number 19 is asking us to simplify 5f plus 7g minus 8f plus 2g. So what I will have to go ahead and do is I'll have to first identify my like terms. So my like terms are 5f and negative 8f, and also 7g and 2g. Now, like terms have the same variable and power, So I'll first put my like terms beside each other. So 5f minus 8f, 7g plus 2g. Now 5f minus 8f is negative 3f. 7g plus 2g is 9g. So what I've done is I've put the like terms beside each other and I have gone ahead and simplified. You can only add and subtract terms that are like. So there's no way that I can put the 3f and the 9g together. Now I have h squared times h to the power of 5. Now when we have the same base, we can add the powers together. So that becomes h to the power of 7. The square root of 16x squared times 5y to the power of 0. I will first go ahead and work out the square root of 16x squared. The beautiful thing about 16 is that it is a perfect square. So the square root of 16 is 4, and the square root of x squared is just x, because of course x times x gives us x squared. Now we also know that any number to the power of 0 is 1. So that's just 5 times 1 right here. I'll just write 5. So 4x times 5, 20x. Balavan has n marbles. He gives his sister n over 5 marbles. He gives his cousin n over 2 marbles. Write an expression in terms of n for the number of marbles that Balavan has. No. Give your answer in the simplest form. So guess what? I have n marbles. And I'm giving my sister this amount, so I have to minus that. It's n over 5. And I'm also giving my cousin a portion. Now I have to go ahead and simplify what I have right now. Now, I can think about n as being n over 1. Why am I doing this? Because I'm working with fractions and I want everything to have the same denominator, because I'm going to be subtracting. Now, I have denominators of 1, 5, and 2, and our lowest common denominator is 10. So you just find the LCM of all those three numbers. The lowest common denominator is 10. So I want all of them to have a denominator of 10. To convert n over 1 to have a denominator of 10, I times the top and bottom by 10. So this is 10n. For this one, I times the top and bottom by 2, 2n. And for this one, I times the top and bottom by 5. I will now go ahead and subtract. So 10n minus 2n is 8n. 8n minus 5n is 3n. So that's my answer. 3n over 10, or you could just say 3 over 10, and then the n. So now we've gotten down into set notation. Use set notation to describe the shaded region. So of course, what we're seeing right there is our intersection. So it's just the intersection of A and B. So A intersect B. For B, it's asking us to find the number of elements in set C. So the number of elements in set C would have been 1, 2, 3, 4, and 5. And just a point to note, for up here, your intersection sign is an upside down shape like this. It's not an N or an N, it's just A, B. And down this portion, this N is just asking us to find the number of elements in that particular set. So that's 5. Now 22, we're instructed not to use a calculator Now, what we're going to have to do is we're going to have to work this out. You must show all your working and give your answer as a mixed number in the simplest form. This is important because if you do not give it like this, you will lose a point. Now, I have 2 and a third times 11/14. I can convert this into an improper fraction to make the multiplication easier. 2 threes is 6. 6 plus 1 is 7 over 3 times 11 over 14. So now we'll go ahead and simplify. 1, 2, 11 over 6. Now, are we going to leave it as 11 over 6? No, because it told us to leave it as a mixed number in its simplest form. So what I will have to do is I'll have to go ahead and finish working this portion out. How many times does 6 go into 11? It goes in 1 time with a remainder of 5. So this is our answer. Number 23, expand and simplify. We can do this through FOIL. So first, FOIL goes like FOIL. I will first multiply the first term in each bracket. So I did the x times the x, and I got x squared. Then O represents the outer ones. So x times -5 is -5x. I is the inner. So we have 3 times x, which is just 3x. And then L is for the last. So the last one in each bracket is 3 and a -5, -15. So x squared minus 2x minus 15. And remember to please put your answers on the line. Some of my answers are a little bit too big because I'm writing on the screen to put on the line, but once you are writing on your paper, then you should put them on the line. Renuka's teacher asked her to factorize 8x squared minus 12x. Renuka writes 2x, open bracket, 4x minus 6 as her answer. Explain why she does not score full marks and give the correct answer. Now, as you can see, she has not completely factorized this problem. So the correct reason is that this is not completely factorized. So 2x is not the highest common factor that we can take out. The highest common factor of 8 and -12 would have actually been a 4. So I can take a 4 out and then an x. So 4x should be on the outside, and then on the inside, I would have had 2x minus 3. Igcse thinks of 2 whole numbers. Both numbers are greater than 6. The lowest common multiple of the 2 numbers is 90. The highest common factor of the 2 numbers is 6. Find the 2 numbers. So now, if the highest common factor of both of these numbers is 6, that simply tells me that these numbers are multiples of 6. So the numbers could be 6, 12, 18, 24, 30, 36, 42. And I'm just going to pause here. So we know that they're greater than 6. So of course, this could not have been there. The highest common factor of both of these numbers is 6. So that's what I used to recognize that it has to be somewhere here. And the LCM of the 2 numbers is 90. No, the LCM of the 2 numbers is 90. So I'm thinking about numbers that have multiples that would have included 90. Now I know for sure that 18 has a multiple of 90. I know that 30 has a multiple of 90. All right, so it's 18 and 30. Thank you for watching, and if you need assistance, of course, check the description box for more information.